A tiny speck of dust, no bigger than a grain of sand, plunges into our atmosphere from space at terrific speeds, making the air around it glow as it passes, and we watch it go by in marvel. Doesn't seem much like a thread, does it? But let's say that the grain of sand is roughly the size of Paris, passes through the atmosphere and does not disintegrate. The sight wouldn't be of pleasure and bliss, but of death and destruction. This happened off the northern coast of the Yucatan Peninsula in the Gulf of Mexico. The resulting impact rattled the earth to its very iron core, uplifted crustal material and sent it raining hellfire across the globe and permanently ended the lineage of all dinosaurs. But wasn't that like 66 million years ago? How does that affect us? Well then, let's talk about something that could concern us. In 1908, above a sleepy forest in the Siberian taiga near the Tunguska River, in the day sky, something flashed. Something so bright that a man 20 kilometers away was perforced into taking his shirt off, thinking as if it was on fire. Something so bright that it was momentarily brighter than the sun. Locals said that it looked like some fiery ball going off north. The asteroid approached with a velocity of 27 kilometers per second, and it was responsible for charring and flattening of over 80 million trees, and released an equivalent of 3 to 5 megatons of TNT. The resulting shockwave, the largest in recorded history, was as powerful as 2 Hiroshima bombs. I'm sorry. 200 Hiroshima bombs. Fortunately, the area wasn't populated much. 30 people were knocked unconscious and reportedly 3 died. A few hours passed and astronomers in Asia and Europe claimed to have witnessed a midnight sky so bright that you could read newspapers without bulbs. I mean, you'd expect this asteroid to be at least a kilometer big? It was around 50 meters at best. And then it happened again in Russia in 2013. An asteroid approximately the size of a school bus entered the atmosphere undetected and blew up about 30 kilometers above the Earth's surface. What followed the explosion was an ominous brittle silence for the next 90 seconds. Then followed a shockwave so powerful that it circled the globe twice. Indirectly, more than 1,500 people were seriously injured. Some 7,200 buildings in 6 cities across the region were damaged. And if you still don't believe how threatening asteroids can be, here's what Stephen Hawking had to say about it.
One of the major threats to human civilization is an asteroid. I am alive. This man has locked me in this basement.
Excuse me. If there is one thing and there is another thing, they will bump into each other. Might take a few thousand years, even more, but they surely will. Be it stellar remnants like neutron stars crashing together, unleashing bursts of searing gamma rays. Be it black holes, planets, whatever it may be. The inevitable few thousand feet of orbital misfortune from our side, and we could lose a population center at a level unheard of, even after the advent of nuclear weapons. But one begs to differ. We've landed man on Moon, on Mars. We have giant telescopes looking millions and billions of years back in time. If there is ever a chance in history of human civilization to alter a life-threatening rock's course, it is right now. But we still miss it, like 90% of times. Why? Because asteroids are notoriously hard to keep track of. They are made up of leftover materials from formation of planets, most of it locked up in stable reservoirs, the asteroid belt. These stable reservoirs, being not so stable, continuously leak debris into interplanetary space, potentially crossing with planets. Most of the debris that collides with Earth is harmless, but our planet still bears the scars of collisions with much larger bodies. Asteroids are unpredictable. Their movements are constantly in flux. You could track them for a few weeks and have a solid estimate of their path for the next decade, but after minute interactions with its neighbors or even giant planets far away can send it into a wildly different direction, potentially making for a good view with the misses, or wiping us out. A bigger object will reflect more sunlight, making it easier to detect. But a smaller object has to come really close to Earth before we can make them out. By bigger, I mean at least a few hundred meters. Objects the size of Chelyabinsk are considered tiny. On 26 September 2022, a piece of machinery not bigger than a school bus was crashed purposely into an ancient 200-meter asteroid. This was an international mission led by none other than NASA as a test to purposely alter a celestial body's orbit. The DART spacecraft will strike the asteroid head-on and change the asteroid's path through its transfer of momentum. The mission was known as the DART mission, the Double Asteroid Redirection Test. DART was the first ever space mission to demonstrate asteroid deflection by kinetic impactor, i.e. our first space jihad. It's not the first time that we have crashed a spacecraft purposely into something. We have crashed into different asteroids in search for samples. There was NASA's Deep Impact mission in 2005. It was designed to study the interior composition of comet Tempel 1 by releasing an impactor into the comet. It is thought that the collision managed to change the comet's orbital velocity by not more than 0.0001 millimeter per second. Now, on the other hand, the DART spacecraft managed to shorten the asteroid's orbit by a substantial 32 minutes out of its 12-hour period. Now, I don't think people understand the gravity of what just happened here. We managed to change the trajectory of an ancient body that was minding its business, doing what it has been doing for time incomprehensible. A 600 kilo celestial body 11 million kilometers away from us, and we managed to change its course in less than a year or two. Now, you could use this technology to protect the human civilization from threatening objects. That will be wonderful. But we could potentially create another threat for us which could be far, far worse. The odds of having to deploy a machine to alter a life-threatening asteroid's path in any 50-year period is around 1 in 10,000. The possibility of misuse is much, much higher. The same technology used to protect Earth from asteroids could be used to cause asteroids to hit Earth. You give it some time for proper skills to develop, and you could target asteroids small enough that it could go undetected and crash on a very specific location, a big populated city or agriculturally critical region of enemy nations. Now, who would do such a terrible thing, right? And how about a small error happens in the process? When redirecting an asteroid, some unanticipated gravity bullshit happens, and wow, once considered as a safe location is now in the firing line due to another nation's mistake. Let's hope that we catch that nation in a good mood that day, so they don't nuke us in return. How far are we from actually moving celestial bodies in space with precision? Let's say a few more decades. And how about shifting actual planets? Could be a long time, and the idea does seem a little far-fetched, but not impossible. So what if we could use this technology to push Mars from its cold orbit, or even detach moons of Jupiter, Europa and Ganymede, and bring them inside the habitable zone? Wait, we're getting a little ahead of ourselves here. Let's try to understand this. A habitable zone is the distance from the sun that is either not too cold or too hot for a soup to form, in which DNA and protein can swim around, interact with each other, and carry out the reactions required for life to conceive. We call this soup water. So yeah, you could move Mars from its colder section of the habitable zone, but Mars right now is not much more than a barren rock, and too small even. To hold on to an atmosphere and to maintain plate tectonics for billions of years, a planet must be a little larger. Arguably at least 30% Earth's mass, like Venus, and if a planet is larger, like twice the size of Earth, then it begins to draw an atmosphere of hydrogen and helium, like Neptune and Uranus. Now, the Kepler mission by NASA in 2009 alone discovered more than 2,000 planets similar in size as of Earth. And as of right now, more than 5,000 planets have been discovered. Suppose we filter them out. A few hundred with bad atmosphere, a few too dry, a few too wet, one with bad climate, hostile environment, highly unsafe for women alone. Okay, Delhi kis tale kahan pe? So after the filtering is done, we should be left with at least a few hundred planets. Perfect in mass, radius, atmosphere. That's good, because we're going to need them all. That's right, all. So for a star like the Sun, you could fit 6 concentric circles within the habitable zone. That is just right for water formation. Now you could move in those filtered planets, each on one orbit, 6 planets that can sustain human life, each prettier than the last. What next, you ask? Well, then we leave our old homes for a newer one, just to recreate what we're running away from. But let's take this hypothesis a little further. 2 planets can share the same orbit, stably, which is the keyword here, just as long as one is 60 degrees ahead or behind the other planet. They are known as Trojan pairs. So this doubles the amount of planet on a given orbit. We now have 12 worlds, which is indeed something special, but we can make it much better. A region around an object where its gravitational influence is greater than any other celestial body near them is called the Hills region. Anything outside this region is doing its own thing. Now the reason we only have 6 orbits is because anything closer makes the orbits unstable and the planets will crash into each other. As it turns out, there is a stability limit for the number of planets that can be spread along the same orbit. The limit is simple. The planets sharing the same orbit must be separated by a given hill radius. This number changes depending upon the mass of the planet. The bigger the mass, the higher the hill radius. But for planets with similar masses of Earth, you could stably work 42 planets around the Sun in a single orbit. That is the maximum number of Earth-like planets that can fit inside the Earth's orbit today. A stable system for billions of years to come. Now comes the second ring, the third, the fourth, fifth, sixth ring, each with 42 planets of their own. That is a total of 252 life-bearing worlds, a sight to marvel. a civilization to be feared. When one looks up at the night sky, he sees an intergalactic empire, a civilization of conquerors. And fuck it, we'll ride across the solar system just for the fun of it. It was no goat or no cat. We are Homosapiens. And there will be a day across all the worlds where everyone, all trillions of us, will gather in one place and examine all the planets. Which one is the most polluted or which one has run out of resources to utilize? Then we get ourselves a new world from the lined up suitable candidates. Then we'll purposely push the useless one onto a trajectory where only the cold darkness of interstellar space awaits it. Unlimited resources, beautiful landscapes that will require more than 100 lives to appreciate. If we ran out of energy, we'll use the goddamn sun for it. Everything we could ever want. Everything, but just not enough. Whatever exists in this universe without our knowledge exists without our consent. We are the masters of our ships, the gods of our fates. We are Homo sapiens. And we will never die. 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 Okay, so enough with the megalomaniac rant. Where did we even begin? Yes, asteroids. So according to this paper, the actual chances of a life-threatening asteroid actually hitting Earth is 1 in 6 million years. So if by any chance you're losing any sleep because of this, I would suggest not to. And yes, about establishing an intergalactic empire. It's possible, theoretically at least, but otherwise highly impractical. I just wish, there was a realistic way to avoid this threat. Like someone who had the guts to just face it, like head on. Like the mission Destroyer in the 50s. Oh, you haven't heard about that? Well, it's a good thing they had cameras.
The asteroid's distance from Earth is 3,000 kilometers. It is traveling with a velocity of 25.73 kilometers per second. All systems are go and we are approaching the 20-second mark. Mr. Macaulay has control of all the vehicle's critical functions.
That is correct, mission control. Over.
We're 15 seconds away from the liftoff of the destroyer. Let's light the scanner. 10, 9, 8. Ignition sequence starts. 5, 4, 3, 2, 1. Liftoff. We have liftoff. Inquiring orbital weight over.
Mission control, this is the captain speaking. Reporting orbital weight 63,280.7 kilograms. Everything looks good. For everyone at home, let's blow this rock into pieces, boys. That was the chair. Over. Let the record show that was the chair. Over.
Estimate distance of the rock from the spacecraft is 650 kilometers. Over.
We see it, mission control. Hold on tight, boys. Releasing the striker in 3, 2, 1. Chakka, chakka. I repeat,